Hey, everybody, how are you? This is Eric Johnson, and this is Serverless Office Hours. And guess who's with me? This is Justin Callison. Did I get it right?
Callison, you got it.
Callison, yeah, and I said Callison at first, but that was, it was somebody else. So Callison. Justin, tell us who you are.
I'm the senior manager for Step Functions over here at AWS, and so my team is responsible for the Step Functions service. So it's awesome to be here. Thanks for having me.
Oh yeah, I'm really excited. So today we're going to get a little deep into step functions. We're going to be talking about not just hey, here's some orchestration. We're going to be talking about here's some orchestration, making it really really fast, right?
That's right.
All right, that's right. and so tell us what's the trick there? And we're going to demo this, but what's the angle? What are we doing here?
Yeah. So what I'm going to demo today is a test runner application that I wrote using step functions. And so tests are the sort of thing where like you want to run lots of them. And the problem is if you're running lots of them, they're going to take longer, and that amount of time becomes a problem for you. And so if you want to shorten your time, but you also want to have a lot of that stuff, you want to have parallelism. And running things in parallel is great. It's usually simple when you have a couple of them, but when you get to a certain scale, it becomes a really hard problem. So I'm going to show you how to use step functions to solve that parallelism problem and take advantage of AWS resources in order to push that parallelism, to a pretty high level, and be able to let step functions take care of a lot of the complexity of doing that.
Awesome. All right. So when you say parallelism, would concurrency work as well from there? Okay. Yeah, all right. Exactly. Right. So we talk about running things at the same time, and a lot of if you've watched me talk at all, and a lot of the other developer advocates on serverless office hours or in some of the talking we do, we talk a lot about being efficient with our code, and rather than being linear, we say spread it out. Try to do as much as you can at the same time. We talk about asynchronous versus synchronous, different patterns. And serverless opens up a lot of these ideas for you and these abilities, especially with the managed services like a Step Functions or Event Bridge or SQS or SNS, where they allow us to kind of move these events around and trigger or invoke multiple services. So this is really cool. I know that you had worked with Rob on this a little bit. I know he was pretty excited about that. Yeah. So shout out to Rob. Glad. Hope you're watching. So all right. So what I'm going to do is I'm going to turn it over to you. I'm going to bring your screen up, and then I'm going to let you kind of walk through what we've got going on here.
Awesome.
And there we go. There it is. I got it.
Okay. So this application, I put out a blog a little while ago you can find here that talks a little bit more about it. And it's a serverless app model application. You can just grab it from GitHub as well. So I just got this running here.
We'll post a link here shortly to that as well.
Yeah. So I've already deployed it, but this is where I did it from my Cloud9 environment. So I'm just going to pop over to Step Functions here and so to show you how it's made. Sound good?
Sounds good.
Okay. So there are a few pieces here, and one thing I'll start out with is when you're dealing with a complex problem with a lot of pieces, a common and helpful way to deal with that is to break it down into smaller chunks. Decomposing it into smaller pieces makes it easier because you can have these smaller pieces that have a single responsibility. They're easier to understand, they're easier to manage, and it turns out it's actually easier to accomplish scale and concurrency with doing so. So what you see here are 4 state machines. This first one here is a stand-in for what your tests would actually be. So all this thing does is kind of a dummy thing, and it just runs, waits for a few seconds and doesn't do anything. So when you're building your actual test run, this is where you would plug your tests in. So that's where we start. This main is the primary state machine, the one that you go to. This is how you kick off your test runs. The distributor is responsible for taking those, breaking it down and invoking the independent pieces so that we can accomplish that parallelism. And then this one I'll talk about a little bit later is just responsible for recording the results of a given test. Make sense?
Yeah, it does. So I'm going to stop you here now. Okay, so let's go back to test runner test. Simple wait. So this is firing off. Now, is this firing or invoking a Lambda function, or is it just doing a wait without a Lambda function?
Right now, this is just a wait in step functions. Yeah, so it's not. It's just doing a wait in step functions using an express state machine.
Okay, so if I wanted to test something, then I could easily swap that and say, all right, invoke a Lambda function, and that Lambda function could call an API or invoke an SDK call, something like that, to do the actual tests.
That's right.
Right. Okay.
And you could write multiple of these state machines and have them invoked differently, maybe for running different types of tests. Those might call out to Lambda functions. They may invoke containers. Step functions integrates with a large number of AWS services. And so however you would want to accomplish those individual tests, you can just wrap them up in this.
So would this be an effective load test?
Yeah, you could use this for a load test for certain things for sure.
Okay, awesome. I know that's one of the challenges that we have is, and I don't want to take the wind out of your I don't want to steal your thunder. There it is. Take the thunder from your sails. I'm not good with colloquialisms, but I'm just proud I was able to say that word. We're going to talk about reporting. You have some reporting going on here as well, right?
Yeah. Why don't we jump in and jump in and look at this? So, and before I get started, I just want to cover a couple things. So, there's a bunch of benefits that step functions gives you by modeling this as a workflow and taking advantage of those capabilities in step functions. But there's some other stuff that's actually worth highlighting too. So with step functions, we have integration with CloudWatch logs. And so you can just, with a setting, turn this on. And here I've chosen one CloudWatch logs group. And so now all of the execution history from all of these different workflow executions, they'll all get pushed down into that same place. So it's really easy for me to see what's going on, to do monitoring of that, and to maybe debug if something happened that I wanted to have a look at. As well, you can see here, you can just with a click of a button enable X-ray tracing, and that'll give you end-to-end tracing, which is also pretty cool. And I'll show you how that looks a little bit later.
All right, so I'm gonna interrupt you for 1 second. Yeah, I told you I was gonna interrupt you a lot. So can you go back to that screen that showed the step function layout? And we have already. I think it was showing the. There you go. So real quick, can you give the elevator overview of what is step function, and then I have a follow up for you.
Sure. So step functions is a workflow service, and it's built around the concept of visual workflows and the concept of a state machine. So a state machine is a concept that's pretty familiar to technologists, and it's it has a few different types of states. So a state machine is made up of a collection here. You can see it's defined using the Amazon states language, which is our own language. It has a collection of these states, and these states can be a few things. So there are typical ones you might use for flow control, making choices, passing data around, all of that stuff. But then the ones that are the meat of the work are what we call tasks. And so those tasks can then execute work. So that's how it works. And you can compose these together into a state machine, describe the flow through, and then you can actually look at your business logic visually. And then also we'll show you here, you can actually watch it as it's running.
Awesome. Robert Tables was very excited that you said it's a state machine. So we threw that up there. So here's a follow-up question. There are two types of state machines or step functions. Right. Express and standard. Can you do a quick overview? What's the difference between or express versus standard?
Yeah, you bet. So standard is the initial type that we had when we launched step functions, and it has a few properties to it. It has what we call an at most once execution model, and so this is really good. Where if you're orchestrating things in your workflow and you want to make sure you don't do that thing more than once, it turns out doing that in a distributed system is actually a tough problem. And so being able to take care of that for you is actually a big part of the value. So it will checkpoint as it's moving along, and it'll make sure that it doesn't execute any of those steps more than once. So it's really helpful there. Standard will store the results in the service, so you can go back and ask for it and see these visualizations in the console or via API. Those can run for up to a year. So that's what standard is. And so it really handles these really durable, really robust workflows that can handle anything you want, long periods of time, etc. So it's really the general purpose starting point. But what we found was we had a lot of customers who loved the concept of step functions. They loved the state machines, but they wanted to use it for really high velocity, high volume, short duration workflows. And in that case, standard was just a bit too heavyweight for what they needed to do. For example, processing events, everything that comes through into an S3 update, etc. And so that's where we came up with Express. So it's very similar. You define it using Amazon States language, just like standard. And you'll see it here in the console. It works the same, but it has an at least once execution model. So there is a small chance that it could run more than once, and if it fails, you restart it. You'll have the same thing with your SQS messages. As well, they run for a short duration, only 5 minutes, and they don't store the data in the service, but they can emit off to CloudWatch logs. And so we built these so that it would have the performance and cost characteristics that are commensurate with that high volume, short duration type of workflow. And so we have both of these, and as you'll see in this case, it's not a one or the other. You can actually use them together and combine them. We call composing them, and it's a really powerful way to get the best of both worlds.
Yeah, and Callison, thanks for asking that question. Yeah, that's often a question we get. And then I'll take it one step further. Now my man Rob Sutter, he would always say, I think all interactions with you should always have a step function. And I fought him on that. I'm not going to lie. And then the Express came out. I was like, okay, yeah, maybe. But if I'm just talking to Lambda, stuff like that, I don't know. But then synchronous execution came out of Express workflows. And so if you're not familiar, so Express was only asynchronous, right? You start it and it does all these things, and then you can check for it to finish. But now you can synchronously invoke them, and so you actually so if I'm putting API gateway in front of it, which I can talk directly from HTTP API directly to step functions, and I can say invoke this synchronously, and then it will actually wait. It's a blocking call. It will wait for the response from it. So you can do a lot there. I have an example I built where I was generating signed URLs for S3s. And saving it to a DynamoDB and getting it all ready, and it would respond within still milliseconds. So, very, very, very cool. So,
yeah, thanks for bringing that up. I won't get into synchronous here, but I'd love to come back, maybe bring Tanya, and we could demonstrate some of that stuff. The options are amazing, and what we can do. Right. We're really excited about what people are going to build with that.
Consider it done. So if you're asking questions, and I'm seeing questions coming in, these are great. We're gonna the format of this is we demo some stuff, we answer questions. This is an Ask Me Anything. So if I don't answer it right away, we'll get to it. So and we're gonna try to answer as many as we can on screen. So we'll come back to a few questions in a few, but I'm gonna let Justin continue to show what he's shown here.
So why don't I just kick this off here? So I'm just gonna start by kicking off one of these things. And so the way I've built this is it starts out by, and what we can do actually is we can just pop up here, have a look at the workflow and see how it's progressing. So at the beginning, it basically just does some setup and it prepares the test input, the test run input, the things to be run during the test, and puts that off into a file in S3. And the reason it does that is because I talked earlier about how we're going to have a little parallelism in a large number of these things. The way Step Functions works is you can have up to 256 kilobytes of data passed as input from one state and into the next. And so you don't want to put your entire data set through the workflow state. It's just too much. It's too much data, and it's not really where you need it. And so what this demonstrates is a common approach where you put the data off into S3 and then you pull in the stuff that you need. And so it does that. It then kicks off this part that actually loads the data for each batch. Let me just pop out here one sec.
You can use Dynamo for that too, right?
That's right. So yeah, that's actually an interesting point. Let me just, now that you mentioned it, I want to show this. So here's my state machine definition in the Amazon States language. Starts out with this choice. You can see these things that were visualized. So here, this is a task, the thing that does the work. You'll see here that I'm using the service integration with DynamoDB. And you have, if you're familiar with DynamoDB, you'll see down below, this looks like just a put item call. And so the cool thing here is you can construct that API call in your workflow definition, and it just calls straight to DynamoDB. You're not having to manage any code, any small shims in order to do that. It just handles it completely. And so this will record the data in DynamoDB to capture the tests that were run.
We see a lot of common patterns where people will fire or invoke Lambda functions to do this. You don't need to. Lambdas are for transforming, not transporting. So when you can talk directly to it, do it. I need a pointing that.
Yeah, I mean, it saves you a bunch of stuff. You have all those little pieces. You have to take care of all of them. So it's really helpful to have them taken care of that way. All right, so here you'll see when those batches, this comes back, it actually includes the S3 bucket and the key. You'll notice this is an array of batches. And so another thing about the way step functions work is the amount of concurrency in this map state, which I'll explain a little bit, is limited, so it'll run 40 at a time. And so what I wanted to do is to make sure that the larger workflow I'm building won't be limited in concurrency. And so I made sure here that it's going to return only up to 40 items in this array. And then the values from this array are then passed into this, what we call a map state. So a map state, and I'm going to pull up the definition here because it's probably a bit easier to see. Whoa, that didn't work. Let me find it. Okay, so here's my map state. Map is for dynamic parallelism. And so what it allows you to do is in this state, I can define this iterator, which as you see is just another state machine definition that's nested inside. And by doing this with map, I pass in an array, and for every item in that array, step functions will start in a parallel execution of that iterator state machine dynamically for you. So you can have whatever parallelism you might have one time, which is this case, or later we'll see more, and all of that parallelism is handled for you. That sounds simple, but it's actually a really challenging thing to do on your own, and it's incredibly powerful. Our customers love this.
So just so you know, and I'm going to do this and see if I'm right. Map state allows you, it's an iterator, right? And so I'm mapping through. Now I'm using the word in the definition, but it's an iteration, correct?
Yeah, exactly. So it's map says, okay, I have an iterator, which is another state machine. And when I pop up here, that's what I see here. So these three steps together. So this is an independent state machine. And what you say is, hey, I have this state machine that's nested inside of my larger workflow. And what I want to do is for whatever comes out of build batches, this state here, if it's an array of one item, then it'll initiate that iterator for that one item. If it's 100, it'll initiate it for 100 of them. And so those will be done, and they'll be done independent and in parallel.
Okay. All right.
Make sense?
It does, yeah. And just so you know, if you've never demoed live, it's really hard to make your font big enough for y'all to read and still do it. So when he's jumping around like that, it's hard sometimes. So there you go.
Yeah, sorry about that. I'll try my best.
No worries.
Okay, so what I'm going to do then, so we've seen what happened here. It comes in, it loads up the data that it needs from S3 for that particular batch. And here we can see it's tells the number of the test, the duration it's going to delay. And so this is where if you were doing your own, you would put in greater instructions for the test that you wanted to run. Then runs this distributor, and then it finishes up after. And at the end, I end up with this output. So this is the output from the execution. It tells me, hey, how many tests were run, what was the average duration, what was the fastest, and it'll return to give me the test results here. And so it's done that because in that distributor, it's stored this data in S3, and then this here grabs a test and generates that test report and generates that at the end. So what I want to do here is then jump through. So if I scroll down, I look at the execution history for this. I can see a link off into that child execution. So what happened here is in my state machine, in that iterator, I specified a service integration with step functions itself. And so when that happens, what happens is step functions will say, okay, I'm going to take that input, and I'm going to pass it to another execution of step functions and have an independent execution that it'll then track and handle the response and pull all of those together. And this is what allows me to have one starting point that then fans out into a large number of additional ones. Does that make sense?
Yeah. Yeah.
Cool.
Just so if you're interested, I've just posted into the chat the link to Justin's blog, which has a link to the code as well if they want to run it themselves. Is that correct?
Cool. You bet. Yeah.
Cool. All right.
Excellent. Okay. So this one comes in, it makes a decision here, and it says, okay, are there the input that I've been given to this distributor? Are there more than 40? And if it's less than 40, then it calls into another map that it executes that test state machine, which would be the actual test. And then it calls into the result recorder. And so here I come in, if I had 40 of them, then it'll spin those up. It also does something, and I'll show this after. If there were more than 40, it wants to make sure that we have them all running in parallel. So what it'll do is it'll actually use recursion, and it'll actually call back to itself. It'll break it up into a set of 40 batches and call itself, such that this will continue to fan out just arbitrarily to what you need.
Now, the 40 is just a limit you've imposed. That's not a step functions limit, right? That's just
a step functions limit. That is
it
a
is
step
a step
functions
function
limit.
limit. Okay, got it. All right.
Yeah.
So go ahead. Sorry. Well, my question is, did you have to set that 40, and then so did you have to handle that recursion, or is step functions doing it on its own?
So I wrote the code here, or defined it in my workflow to do the recursion. The limit of 40 is a part of how the service works. And so that's just part of how it works. And so we have to work through that. You can control concurrency to be less than that if you want. But
is that a soft limit? I don't mean to keep interrupting you. I apologize.
No.
Okay, that's a hard limit. Okay, got it.
Yeah, it's a hard limit of the property of how the service works.
Excellent.
Okay, so all right, so you can see it runs that test, gets the result, and then passes it to this result recorder. I'm just going to jump over and show that a little bit here, because this is the case where the distributor is a standard one, so it has all of those checkpointing capabilities that I talked about. But this result recording, there's actually quite a few steps that I needed to do here, and so I thought this was a good use for Express workflows. So you see all of these are going to happen off in Express, and it grabs the input, it checks if it was a success or failure, it records custom metrics in CloudWatch metrics using a Lambda function to invoke those, so that you have that data there. It also does something to say, this is a classic thing. You don't want your duration metrics to be polluted by failures. And so if it was a failure, it doesn't add it to that metric. This is why you see the logic. And then it records it in DynamoDB. I'm also going to show you something here, which is a really important part of the value that you get from step functions. So if you look here, this is in my workflow definition for one of the states that records metrics. I can just specify here a retry policy that says, hey, states.all means on anything. Retry it with a backoff rate of 2, exponential backoff, maximum attempts of 3, and step functions just handles that for me. There are lots of reasons why things can fail. We can have throttling, we can have a whole bunch of other things, spurious, and you don't want to have anything like that. Werner Vogel's talk says, everything fails all the time. And so this is a great way for you to accept that, describe it, and then make sure that it'll be handled. So you'll notice, sorry, go ahead.
I want to take a moment on that, because I feel like this is often it's either overlooked or it's added after the fact. And going back to what Werner Vogel said, everything fails all the time. I would love to tell you at AWS we build things that never ever fail. But what we do is we build things as if they will fail, right? We always look at something and go, hey, as robust, we built some robust stuff. I mean, that's the truth. But as robust as your code is, things happen. That's just life. And so and in the services like we're looking at right here, there a lot of times your retry logic is built right in. I can't tell you how many developers I've talked to who they're writing this kind of retry in their code. And it's wasted code. It is undifferentiated heavy lifting that you shouldn't have to do when it's built right into the service. And it's built into a lot of services, SQS, Event Bridge, SNS, things like that. So really be aware from the beginning and plan as you develop to add this stuff in. And I think Justin's code here is a great example of that.
Yeah, totally, Eric. My go-to is I put a retry on states.all for everything. I start there. So I'm going to retry on everything, and then I decide whether I want to do something less or something different. But you always want to include a retry because, and if you have cases, this is quite flexible. You can have a handler to say it's going to retry on everything, but then you can put a priority before that for, say, a specific exception, specific error that you're going to see that you want to handle differently. So it's super flexible in what you can do, and there's lots there. Now, the other thing I wanted to then call out is you can also have a catch block that says, okay, we'll say even after your retries, this thing fails, what should I do? And so you also want to have a catch there to make sure that you handle these failures and you don't have your workflow just fail completely. So what I've done here is I've actually said, you know what? I'm considering the storing of metrics in CloudWatch metrics is optional for this. If it doesn't work, I'm not too worried about it. And so that's what I described. I'll catch that and I'll say, you know what? If that does fail, I'm just going to continue on. And I'm only going to limit the number of retries that I have here. So I was able to just describe that behavior and say, this is what I want to have happen. And the system takes care of it for me. Whereas when I move down here and I'm writing to DynamoDB, which is my system of record, I'm trying a lot harder. I'm going to a lot harder attempts, and I'm not going to catch. I'm going to let this thing fail if for some reason I was unable to do that. So this retry stuff is a huge part of the value that you can get from step functions. Not having to write this, not having to complicate your own code with these capabilities is really, really helpful.
Yeah. Grant said it too. He said this retry stuff is really the killer feature of step functions. And you're right, Grant. I appreciate that.
Yeah. So what I'm going to do, actually, sorry, before I do that, let's go back to this execution that I had. And what I'm going to do is click over here and show you. I'd said earlier that I'd enabled X-Ray.
Yeah.
So X-Ray is AWS Tracing, and this is another thing that gets pretty gnarly when you're dealing with especially serverless applications and distributed systems. There are things happening all over. How do you keep track of that? So now I've just clicked the button to enable it, and now I can come in. So apologies, the screen makes this a bit hard to see, but right away I can see here's my main state machine. Here's some of the Lambda functions that it calls. Here's a DynamoDB table it talks to. Here's the other state machine that it called into. This is the distributor. There's the distributor calling the result recorder. So you can see the whole thing.
Can you zoom in on some of those?
I can try.
I know the screen makes it
I don't think
really
I can.
hard.
Sorry.
Okay, yeah, if you can't, don't worry about it.
I might break the universe if I did that.
Okay, yeah.
But,
okay.
Yeah. So yeah, but you can check this out and get it from GitHub, run it yourself, and have a look. It's super helpful. And it's baked in. You don't have to do anything else. You just have to turn this on and take advantage of that capability.
Yeah. Hey, Justin, I want to take a few moments and answer some questions real quick if we can.
Yeah.
Okay, breaking. That was a good segue too. So you got a question here. It says, is there an easy way to visualize the execution history of express step functions like standard step functions? Is viewing CloudWatch logs the only way?
Right now, CloudWatch logs it is the only way.
Okay.
Yeah. However, one of the things that I found super useful is using CloudWatch logs insights. And creating using that to create a query to look at these things and be able to look at it in a list. It ends up looking very much like what you would see in the list of history events in the console. I found that really helpful, and I found it actually better in certain cases when you're running something at scale and you have a lot of different executions and you want to look at them all at the same time. So while we don't have the visualization for it, I would encourage you to have a look at CloudWatch logs insights. It's really, really helpful for getting a good look at this stuff.
Yeah. All right, here's another one. I like this. It says in the standard flow where you store the data of a result, since it can last up to 1 year, as a customer, do we continue to pay for a transition?
With standard, you're billed per state transition. So this is one of the things that Tim Bray used to say all the time. Is like step functions. It's about the only service where it's cheap to wait. So if you put in a workflow, and like most things in the cloud, it's really expensive to wait. But you can put in place a workflow and say, hey, I'm gonna put a wait state and I wanna wait until 2 weeks from now. You don't pay for anything in that time being. When the time comes, the workflow will pick up and you pay for the state transition that happens at that point, but you don't pay for anything in between. So it's really, really great for those cases where you want to bring the dimension of time.
All right, we might need to expand on this one a little bit. There's a question: is there any timeout for step function?
There are timeouts. So you can set a timeout on the execution itself at the state machine level. You also can and really should set timeouts on the individual states themselves, because sometimes you will invoke these things and they may take longer than you want to. And so you want to be able to control that and say, how long am I willing to wait for this? So we have timeouts on all of those levels.
All right. Okay. I think what that is all we have at the moment. We've got some more in here, but I want to let you finish showing some stuff, and we'll come back to some.
Yeah, thanks. So what I'm going to do is, so we did see if I can spell here. I messed this up when Eric and I were fooling around earlier. So I just did one earlier, was just a single iteration, but now let's kick this off and let's try with a larger number. So here I've now done 5,000. So that's that was just in here. I could just specify it. The test this thing will run through. It'll generate that larger set. So here, if I were to look at this, I'll see a larger number of batches that have come through. If I were to go look at that file in S3, I would see 5,000 different tests that had been initiated. Now, if I go over here to distributor, I'm going to see a whole bunch of these running. And I can come back and monitor this whole thing from one place as it's driving to completion. So the nice thing about doing it this way is I have this fan out, but defining the workflow, then it all comes back together, and I can still control and look here. And when this is finished, we will see the result. We will see the outcome of that. And you see now it's finished. It's now generating the test report. And now it's finished. So now if I pop up to the execution output, I can see there are 5,000 tests. They all ran successfully. And you'll see here, I've done this so that if the results that come back from that test report, if the full set of test results would have exceeded the 256 kilobyte state limit, then I just truncate that. You could always go off the DynamoDB to get that.
Right, because DynamoDB is your authority.
That's correct. Yeah.
Okay, got it. Okay.
Yeah, and but now you look at this. So here, this took about a minute to run, and at an average of three seconds per at 5,000, that's over 4 hours of work that was done in about a minute. So it just shows you the power of the parallelism. That if this was real test at 5,000, you run them sequentially, they would have taken you 4 hours, and you could have just run them in a minute. Super powerful.
Okay, so I want to talk use case for a minute. Then we've got some other questions, but so earlier I referred to as like doing load testing, and there are utilities out there. When I use serverless artillery, which is great for load testing, and it does some great things. You can do some authentication, and it pretty much says do this, but you don't have logic, right? You don't have the ability to say I want to do this, 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 and then this. And so that's where the Lambda function comes in. And so I for just a light ping, hey, I want to ping and see if you're up, this is overkill, right? But if you need to do some testing against that and make sure this is working and this is working, and run some steps against an API or website, something like that, man, this is a great use case. Do you have any other use cases you would suggest this for?
Certainly for you could do for load sorts of things. I think that though the bigger one is just when you have these tests that are going to take individually, they're going to take a fair bit of time. Maybe they're calling out to some other things. You don't know how many.
Right.
You're starting it out and you're going to say, oh, I have 5 or 10. This is fine. But I might have 100. I might get 1,000. I might get 4,000. And you want to build something that's just going to continue to scale as you increase the amount of test coverage. Maybe you have dynamic. Maybe certain times through your test pass, you're only doing a small number. Maybe some you're doing a lot. And just having a system that's flexible and it's completely serverless, so you're not paying for anything while it's waiting. The scale is there if you need it, and when you don't need it, it's not used. So that was sort of the case that kind of inspired this. But there are lots of cases that people use this for others. Data processing is a really, really common way of applying common use case to apply very similar patterns to what we have here.
Right. All right, so I got a couple of questions. If you're okay with that,
you bet.
And I'm glad to jump on some of these as well. What things do you consider when breaking up a process from a single Lambda into multiple step functions? When is that point, or what point do you do that? And what about cold starts, etc.? And I'll actually grab this one if you're all right.
Yeah, you go.
And then you can tell me if I'm wrong, but don't say it out loud. So you know what I'm saying. So anyway, what we look at. You have to evaluate how much orchestration am I doing? is some of my code orchestration? Am I doing this and then waiting for response and then doing this and checking different things? That's when you start looking at a step function or a state machine, because I mean that's exactly what it is. It is saving state as you're orchestrating different actions. And I told you earlier, my buddy Rob said, "Hey, state machine should at least an express should always be involved in everything." And I tend to lean that way, because what happens is when we build a Lambda function, rarely does it do, or when we build an application, let me try that again, rarely does it just do one thing. So sometimes it's going to do several things. And so you automatically have this, infrastructure in place to say, okay, I did this, now I'm going to do this, now I'm going to do this. So you break out that orchestration. As far as cold starts, and Justin, feel free to throw in any thoughts you have on that as well. But as far as cold starts, so if you're familiar with how Lambda cold starts work, if this state machine is going to invoke the same Lambda function, in different iterations, things like that, then it's probably going to be warm. The first one's going to be cold, unless you have that same point in time, then your concurrency is going to kick in and it brings up another one. Like anything else, when you're building your Lambda function, there are some things to do to reduce, cold starts. How much code are you running? What are you doing in startup time? How and what I mean by how much code is how many dependencies are you trying to load up? What's the package size? Different things like that. But again, those can affect your state machine. So as you're planning this, you plan accordingly. So anything you want to throw in there, Justin?
Yeah, no, I think those are good things. I mean, we obviously I'm a little bit opinionated on this, given that I work so much with step functions, but we really see value in almost all cases. So just a simple one, if you're doing something in Lambda, maybe you're handling an event, and one of the things you can do is you can simplify your Lambda function by not having to include a bunch of error handling. You can have it be much simpler. It tries to do what it needs to do, and it fails. When it fails, it throws up its hands, and you can allow that error handling to be done through step functions and to do retries, etc. So even in those small cases, it can keep the Lambda code that you write a lot simpler. Also, it may mean that you may have some stuff you were going to do in your Lambda code, maybe to call out to another AWS service. It's just simpler to describe in a workflow and not have to write into some code that you're then worrying about deploying, testing, keeping track of over time. You can just let the service do it. Another really good reason to start with step functions too is just to make it easier to add other things. So you may start out with something simple. You're like, okay, hey, this event comes in from EventBridge, and I want to trigger a Lambda function. That's cool. But if you want to say, I trigger that, and you go, oh, you know what? When I have this and I've taken this action, on these ones, I actually want to send an SNS message to someone else. Then you're just updating your state machine. Simple addition to that. You're not touching that Lambda code. You know it's going to behave the same way that it did before, and you can incrementally add and enhance this and make sure that the actions that are taken in response to that event are flexible and changed as easily as you want them to. This is another reason why we find it really helpful. Yeah,
I would agree. It's that preparation to grow. You know what I mean? Even if you don't think you're going to grow, and you tend to. So I'm going to grab this next one. I'm going to share my screen. So I'm going to take over your screen sharing for a moment here. Let me blow this up for a moment. So we have a question that says, can you remind us again how to enable CloudWatch logs and X-ray for step functions in a SAM template? Well, I live and breathe and eat SAM, so if you don't mind me grabbing this one. One thing I do is whenever I search Google, I always search the actual SAM template resource name. So I'm going to do a search on AWS : service : state machine. And then under here, I'm going to configure my logging under the logging right here. So we do a logging configuration. And you can see here where you just set up, you create a role arm. So you may create your own CloudWatch stream or CloudWatch log that you want to do that, and then point at that. So you'd set that up that way. And then for tracing, you would set up a tracing configuration. And a tracing configuration just simply says, if I click on that actual link and not just highlight it, you're just gonna pass in the tracing configuration. Here it is. It actually takes, sometimes this will link you through, and all you're going to do is say tracing, and then the object is enabled true. And so that'll turn tracing on for that. I won't eat Sam, John. I appreciate you calling me out on that. That is a really good point.
Eric, can you just pop back to my screen? And I want to show something quickly. along what you just described. So Eric showed you how to find this from the docs, but if you go off to the GitHub repo that has this sample project, you can actually see how that's done as well.
Yes.
Have a look in here.
I'm a example guy, so this is good.
So this includes that example. So one of the things that we talked about the ARN, one of the patterns that I like is to actually just create one role and reuse it throughout my my application. So I find it just simpler to do that. And then if I pop down here, I've down below, I've created that log group. And then I'm going to go up to the main state machine, which is here. And you'll see here, I've got the logging configuration there. Right. And
that's the real deal.
Yeah. And then the tracing is enabled here.
Yeah.
So if you want to have a look, that's part of why when I put this example together, I wanted to kind of show a bunch of these things. So hopefully this will be helpful if you want to do some of these things. You can have a look at it, even if you're doing something different. You can have a look at what we've done there, and hopefully it helps you.
I am also pasting 2 links, and these links are, I do a series called Sessions with Sam. If you ever need Sam information, I cover a lot of it there, and they are literally examples, not just documentation, but examples. The first link is s12d.com/Sessions with Sam. That's the streams on YouTube. The second one is s12d.com/SWS repo. That's the example code. So all right, so we have another question, and I'm going to give this one to you.
Okay.
First of all, this isn't a question, it's a statement. Wow, this looks really cool. Never used X-Ray before, need to try it. Yes, you do. It is very helpful, especially when you're building distributed microservices. This is a great way to trace all that. So the next question we had is, any plans on having jitter support for retry? And of course, we can't talk about roadmap, but what's your thoughts on that?
Yeah, we've heard it before. So yeah, I can't speak to any concrete plans, but it's something we've heard before, and we've heard from customers, and we listen to customers and make sure that we're taking those actions. So yeah, we can see the value that would add.
Excellent. All right, so we have a statement here. It's not really a question, but just give this to you, or maybe I'm sorry, there is a question here. I use Event Bridge to trigger my state machine. It would be really helpful to name the execution based on the initial input data. Order ID, for example, order ID. Is there a way of doing this easy to have the console? Okay.
Yeah, it's another one we've heard. It's one as a customer, I've called out too. So yeah, no, not that I'm aware of, unless there's some wizards out there who've solved this. When you're setting up the triggering of step functions from Event Bridge, you cannot specify the name, but it's something we've heard, and I think that would be an interesting thing to add. I want to use this as a chance, though, Eric, to just call out the implications of doing so. So with step function, with standard, the name of the execution for a given state machine is unique for 90 days. So we keep the execution history from a completed state machine execution for up to 90 days before we clean it up. And during that time, you can't reuse that, and that is helpful for idempotency. So say you have something and you want to say, okay, I want to have a workflow done for this order. Well, then you can include it in the name, which I think is what this comment was pointing at, and then we will make sure that there will only ever be one of those that are executed. And so, as I said, distributed systems are complicated things. Principal engineer I work with always says, there's no such thing as exactly once. I'd love to have him on here explaining some of that stuff at one point. So it's a really great pattern. I'll take that back to the team.
Okay. I want to say thank you to Cloud Girl, who has been killing it out there with documentation. And I can't say the name, Thamai, I think, says it gives you compliments. So I appreciate all the help. Really helpful. So here you go. This is an interesting comment, and I'll let you go first, and I have some opinions on this. This is following up on breaking up the process. The basic bottom line of this is, have you or customers ever encountered a situation where you broke up your process too much and wanted to bring it back together? What are your thoughts?
I haven't myself, and I can't really recall working directly with a customer who said that was the case, but I certainly could imagine where there might be some. I could imagine something where, where the things that are happening in a given Lambda function, really, you always want them to happen together. And and you don't want those to be done independently, or you learn that, hey, I really want to have this as one logically consistent unit.
Right.
That's the sort of thing. But that's not feedback that I've heard. Doesn't mean it's not something that's happened.
Yeah, I would say the same. I haven't heard that specifically. I will tell you that I can find myself often getting caught in paralysis of analysis, where I find myself going, can I take this even more granular? What should, and I start, I spend more time architecting than I do coding. And so I think there's a real balance that you strike there and saying, I mean, there are some hard, fast rules, right? You want to be decoupled, right? You definitely want to, so your app can fail gracefully. You want to have your application decoupled so that even though this may fail, these folks are still running, right? So, and we use things like step function for that, and the retry, and a lot of things we've talked about today, or SQS or SNSC queue things up, and if a Lambda can't handle, if Lambda function can't handle it right now, it can handle it later. So those kinds of things. But there's a lot of, there's some thought around, hey, I have this small application, it does maybe two things, one Lambda function's fine. That's all right. Maybe the overhead of breaking out those responsibilities into two is not worth it. However, I tend to think it is. I'm a big fan of single responsibility. So it comes down to preference. Keep the hard, fast ones. Decoupling is a big one. Monitoring, all those kinds of things. But my advice is always code or plan to scale. And so when you start breaking these out into microservices, it makes it easier to scale those out. I do a talk on building a translator that first you're just translating a language. And the pattern I have is using actually Event Bridge in this one I'm building. Don't get mad, Justin. I'm building a Step Functions 1 too. I'm showing the different examples.
We love them.
I saw the red face. I saw the anger. No, I'm just kidding. But yeah, so this particular one uses Event Bridge, and it just pumps stuff into the bus, and then in different rules trigger different Lambda functions or invoke different Lambda functions to handle that. And by using that pattern and keeping that just one single responsibility to a single Lambda function, I'm able to slap another one in, add another rule, and now it does something else. So by staying granular, breaking it down, you really get this advantage of being able to build fast. You get a pattern and building fast. So
one thing I wanted to just keep riffing on there, Eric, you talked about Event Bridge, and the team that works on that, we work really closely with them. And one of the things I find people have a perspective sometimes that I don't subscribe to, which is that you're picking either or. You're either doing orchestration with a workflow engine like Step Functions, or you're doing choreography with an event bus. And that's a false dichotomy for me. You want to do both. These things work really well together.
Absolutely.
And so they're like, peanut butter and jam. So you don't have to separate these things out. And really where Step Functions really helps you is where you have a multi-step process that you really want to have control over how that's handled. You want to make sure that when this happens, that this will happen after, that there's maybe there's state paths between them, then you want to handle that simply. If it is really, from a business perspective, one thing, it's really helpful to put it into workflow. But then there are lots of other cases where you'll want to say, hey, let's just emit that out to Event Bridge and continue on. And there you want to have a looser coupling between those. And so you really want to look at using both of those, just like the question of your Lambda functions, where is the right boundary? It's similar around where the workflows fit and where you're going to be better off out to Event Bridge.
Okay, excellent. All right, we have another question here. Thoughts on trade-offs between SAM versus pure CDK in this space? So if you don't mind, I'm going to grab this one because this is near and dear to my heart. I'm posting a link right now. This is a repository for some code that I'm giving you early access. It's on a blog that I am right smack in the middle of writing at the moment on SAM versus CDK, or SAM or CDK, or SAM/CDK better together. Really, honestly, how you want to title that. So, we get the SAM or CDK question a lot, and I'm going to tell you straight up, it's really preferential. Both work. I guess my hard, fast rule is don't build. You can't scale. The console is a great place to learn, but you can't scale. You can't repeat. And don't build Lambda functions on your own or serverless applications without a framework. I really encourage you to use a SAM or a CDK or a Go serverless. using these frameworks, Chalice and there's different ones you can use. But SAM or CDK, they actually kind of so SAM is declarative. You're going to, hey, I'm declaring a YAML template and building that out. CDK is code based. Hey, I'm going to do it through code, and there's some pluses and minuses to both. But here's the fun thing: is SAM CLI, which we use in SAM for local development testing, things like that, can be used with CDK as well, and it's something that we're working on to improve as well. So those are my thoughts. There aren't. I mean, I could give you some trade-offs. I think SAM. So here's some trade-offs. CDK gives you massive amounts of flexibility, right? With the coding, you can loop, you can iterate, different things like that. You don't have that ability in SAM. However, SAM, because it's based directly on CloudFormation, sometimes it's a little more updated. And I mean, like a little bit. Usually, CDK is right there behind it. So those are a couple trade-offs that I see, but great question. I hope that helps out. So, all righty. Okay, so we have a mic. Okay, sorry if we're having some sound issues. And I'm just going through to see any other questions. All right, so let's pull this one up here. I'm not sure what's going on. It's really hard to throttle calls to downstream services in serverless. Is there plans to add throttle strategy to parallel step function executions or recommended design patterns?
Yeah, so, throttle strategy is we have the retries, and the default way of handling these things is to be optimistic and calling your downstream. When there is a throttle, handle it like any other type of failure. But we do hear this a lot where people want to control, maybe they're calling a downstream system that has a relational database that has fixed scale, and they can't, they don't want to overload it. Overloading it can't protect itself. So we've heard this before. And there are some ways to do this, and actually, this is actually a nice setup. So I think I'm working on a blog post and another example to kind of show how to do just this within step functions. So I'm not ready to share all the details of that now, but it's something I'm putting together. And once that's out, I'd love to come back on here, Eric, and we could talk about that.
I will never say no to you, Justin. This has been good stuff. So yeah, that's great. All right, so we've got some, declarative versus imperative. Yep, CDK versus. So we've got some comments. I like this. Is there are enough bugs in my code? Yeah, I hear you. I'm the same way, but I do like this. Is really cool. I'm a Node. I saw some comments on Node and Python, things like that. I'm a Node developer. Well, there are some people that would debate that, but that's the language I use. Let's put it that way. So, but the cool thing is, if I use TypeScript, then I'm able to really intermix my infrastructure and my my code itself. And in fact, and I'm going to put him on the spot, not you, Justin. He's not on here, but there's a developer named Matt Bonnick who works with the CDK quite a bit. He's actually a hero in several of the AWS groups. Very, very sharp guy. And he wrote, and I'll have to dig up the link, so I'll tweet it out later. He wrote an application that as you add more code or Lambda functions or things like that in your infrastructure, your CDK automatically picks it up and builds the infrastructure. So he wasn't even declaring the infrastructure. He was just simply adding the code file, and the CDK did all the work. So there's a lot of cool things you can do there. But also with SAM, with the serverless specific resources that generate multiple resources on the back end, there's a lot of power there. So yeah, some more trade-offs and pluses and minuses. So, all righty. Okay, got some. All right, here's another question. Can you recommend some resources about AWS offensive testing? Do you know anything about that?
I'm not sure what that. I'm not sure what that means, to be honest.
Yeah, we might need a little more on that before we can try to answer that. I know we have several blogs out on load testing with security and different things like that. But yeah, we might need a little more before we can answer that. All right. I'm just looking here to see if we have any more questions. We have just a few more minutes. So if you have some more questions, we'd love to answer. Justin, do you have anything else you're going to show?
No, I think that was
it. Okay. All righty. Yes. So a Cloud Girl post for throttling. I found this helpful. And Jeremy Daly is a great source. He's a serverless hero. great source for material. So yeah, I can't. I endorse this entirely. He's a really sharp developer and an all around cool guy.
Yeah. So one of the things I'll jump in on that too. So one way that some customers do use step functions and SQS for this is we have step functions has this capability called the wait for task token. And so what it allows you to do is to say, make a call out and include a task token that can then be used, and that state will then wait, and the workflow will wait until it gets called back. And so one pattern that we see customers sometimes do for this throttling is what they'll use that and they'll push into an SQS queue, and then they'll have something pick that up at a controlled level of concurrency to call to a downstream, and then respond back with that task token when it's completed. So that is one pattern that we found customers use, and just building on what was suggested there.
Awesome. All right. Well, we'll give just a minute or so for any other questions. I will tell you that next week, the one, the only Chris Munns himself will be showing up here, and he's going to be talking about something also really cool. This is cool too, but it's API gateway testing and blueprint support for canaries and API gateway testing. And that idea is that you could set up scripts using the canary service. There's a blueprint for it that will do test running. So I guess more along the theme of test runs. So I really encourage you to check it out. Same time, same place next week on Tuesday. And we've got a little more comments on some good examples coming in here. So yeah. So in the step functions workshop, example of waiting for a token. There you go. Thank you, SNR 10. I'm sure I don't say that right. I'm not good with the handles. I'm sure it's not even close. So, all right. Well, that's us. Justin, I can't tell you how much I appreciate you joining us. This was great. Yeah. Great fun. And we have a great audience. I appreciate you listening and joining us today. So with that, I'm going to take us out of here. Again, join us next week. Same time, same place, 10 o'clock Pacific time here on either if you're watching us on YouTube or on Twitch. With that, have a great day. And if you want more, I'm going to throw this out. If you want more content like this, be sure and check out serverlessland.com. We post all our videos, all our blogs, everything. So, and serverlessland.com/office-hours is a full schedule of this, but I'll be tweeting that out as well. All right, all. Have a great one. We'll see you later. Thanks again, Justin.
Thank you.